going through the notes, and there's stuff I forgot all about. 2 times 3 times 7 times 9 is the synodic period of Saturn. If we just take it as a circumference, just those 4 numbers in that order, we get the radius of 378.63. That's to me is amazing. I mean, we've just, used that to times, we get the, synodic period. Just use those numbers in that order and we get as the circumference, and we're getting 378.63. Amazing. So these are just kind of like, this is a notes video really. So D is 72 hertz, 144 hertz, 288 hertz, and on. The 22nd fret, that's where you play the note of D, and also the 10th fret. But if we take the circumference at 453, well, that's the millimeters, by the way, the millimeters from the nut coming down to the 22nd fret, and then with the radius is 72. So I mean, it's giving us the hertz value of D. That's where we play D. That's the millimeters that we measure from the nut, and we get 72 hertz, or 70, So again, it's this Ouroboros, hitting its own tail. This one's a curious one on G, so maybe the Masonic G, but anyway, this is the equatorial diameter of Earth in kilometres, and we divide it by 14. The 17th fret is 14 millimetres wide, and it is, so you divide the equatorial diameter of Earth by 14, and we get 72. 72 gods, 72 demons, and we see that sort of stuff in India and all sorts of places. But it's also the 3rd fret. G is also on the 3rd, so it's on the 17th and the 3rd fret on a monochord. So it's actually 31.5 millimetres wide on the 3rd fret, and as we know with the string length find, 630 millimetres was this divine string length. So if we just take away the dot, it's actually like the octave. It's half the string, but in this case, it's just the width of that fret, the 3rd fret. So maybe Holy Trinity, G, but times them together, 31.5 times 14, we get reversed 144, so we get 441. Another quick one, 12 signs, 12 notes, 12 disciples, 24, hours, whatever, it's important. It's all from sort of 6 and sexagesimal, but it's a perfect number. 1 plus 2 plus 3 equals 6, 1 times 2 times 3 equals 6. So it's this kind of whole, sexagesimal system. If we take the 24th Fibonacci number, 46-368, and the 12th Fibonacci number, 144, we divide those into each other and we get 322. So I mean, it's kind of curious, that skull and bones number, but that's kind of a curious way to get there. And of course 12 and 24 and that are important. You'll remember about the string length, 630 mil. The 126, now this is in the Bible, even in Daniel, was it 1260? This is weights and measures in the ancient world as well. Continuing on with the 630 millimeters for the string length. It's 1/5 of the string length is 126, but 63 plus 63 is obviously 126. So yeah, 1/5 of 630 is 126. For fun here, I'll just put 126 times 4. They say 4 is the Earth number, like the cross, but we get 504. And then I've times it by that little lemma at the end of 6.285 is 2 pi r. So, or is it, no, 2 pi, sorry. So we just take the little end bit, and we get 1440.432. So yeah, just another little bit of note fun. 55 times 144 is the equatorial diameter of Earth in miles, and the synodic period of Saturn divided by 55 is 68.7, which is Mars's orbital period, the distance between latitudes. And as we saw here with this one, we plug in the 1,000, the mile, we take the little bit of a leftover from the circle there, we put it up this side, and we get the hypotenuse of the Great Pyramid, 3,024. So, but we also, as we did that, the values here, the perimeter, is the 687.81. So, as we can see, if we go from the fretboard, fret 2 is 68.7 millimetres from the nut, I believe. Yes, from the nut. So again, you can see all these different ways how they, this is fretboard, that's the perimeter of that triangle, using, the leftover of the circle. Hopefully I'm trying to, piece, because there's so many pieces that do the same thing, but they're completely separate things. Some's the equatorial diameters of Earth, one's the length of string length and how many frets, etc. So we can see that this is one big system that works in the exact same way. 3024, base of the Great Pyramid, and what we've seen earlier. We times that by 2 pi. We get the height of the Great Pyramid. Already amazing to me. But then times 2.858, which is that little leftover bit, and we get 137.5, well, 137.0. So it's basically the fine structure angle again, but just all from, deriving it this way.